All right, so today we are going to learn how to write and calculate using scientific notation. So, the reason why we are learning this, we normally actually learn this at the beginning of the year. We just kind of skipped over the math stuff until we got to the second semester, which is where we're going to be focusing on math. But the reason why we use scientific notation is because if you look at these numbers over here, these are numbers of things like the mass of an electron, mass of a proton, distances between the Earth and the moon, the Earth and the sun, the radius of the Earth, things like that. So some of these are very big numbers and some of these are very tiny numbers. What we do instead of writing out these really long numbers or these really tiny numbers with lots of zeros in front of them is we use something called scientific notation. So it's a way of taking really large or really small numbers and just rewriting them so that you're not writing out lots and lots and lots of digits and numbers. So we deal with some very large numbers. We're going to be focusing a lot this unit on something called a mole. And please don't let mole scare you. It's basically just the same thing as me saying a dozen. So it's just a unit of measurement. So a dozen's a unit of measurement. 1 dozen means 12. Okay. In this case, one mole is 6.02 times 10 to the 23rd molecules of a substance. Okay, so this is a very big number. All right. We also deal with very small numbers. So this is the mass of an electron. So the mass of an electron is super, super tiny. So notice how there's all these zeros in front of it. Well, if I asked you, hey, what is the mass of 1 mole of electrons? If you don't use something called scientific notation, which we're learning today, you would be writing this out. And I don't think anybody wants to spend that time writing out that problem. So, what we do instead is we use a method called scientific notation. So, it's a way that we represent very large and very small numbers, and it's in the form of m times 10 to the n. So, m is commonly referred to as a coefficient. So, this is just a number here, and this number is going to be between 1 and 10. And then the n is going to be an integer. So the n is, a whole number between, it doesn't matter what the whole number is, but it's a whole number. Okay, so we have, it's m, so you're going to have a number there times 10 to the n, which is going to be an integer. And you'll find out what these numbers are in just a second. So let's say, for instance, that I have this number right in front of me, which is 2,500,000,000. Okay, or 2.5 billion. We'll just say that. All right. Now, this number here is larger than 1, right? So it's larger than 1. There is no decimal point. Okay. The first thing you have to do for writing scientific notation is you have to find the decimal point. So if there is not a decimal point, then it's understood that this decimal point is going to be at the end of the number. Okay. So there's our decimal point there. Our next step is we need to decide where that decimal has to go so that there's only one number to the left. So you're looking at your number and we're going to move this decimal until there's only one number to the left of it. So we only want one number on the left-hand side. So in this case, we're going to move it from the tail end to between the 2 and the 5. Because remember, this number here, the number that we're making is the m, and the m is the coefficient, which has to be between 1 and 10. So I can't put the period here, the decimal there, because then that number would be 25. That's greater than 10. I can't put the decimal in front of the 2, because then that would be 0.25, and that's less than 1. It has to be between 1 and 10. So we move the decimal until there's only one place to the left. So this is where the decimal is going to go. Next thing we're going to do is we're going to determine what our exponent's going to be. So we just made our m. Okay, where this decimal ends up, this is our m right here. It's just all the numbers for that part. So it'd be 2.5. Next thing we're going to do is we're going to figure out what our exponent is, so what the n is. So 2.5 times 10 to the what? The way you figure out what your exponent is you count how many places you bounce or move that decimal point. So how many places do we have to move that decimal point to get to there? So 1, 2, 3, 4, 5, 6, 7, 8, and we're finally here. So that took us 9 times. So we moved the decimal 9 places. So this number here, the number of places that we move that decimal point, becomes our exponent. So now we're going to rewrite this in the form of m times 10 to the n. So our m, remember, is just the number that we created by moving the decimal to where there's only one number to the left. So the m is 2.5. Then it's times 10. It'll always be times 10. And then this number here is going to be the number of times we move that decimal. So I move the decimal 9 times, so the 9 is going to be my exponent. Now, one thing I want to point out is that look at our 9. Our 9, is it positive or is it negative? And you will see that it is a positive number. The reason why this exponent is going to be positive is because our original number, was greater than 1. Okay, so the original number was greater than 1. So therefore, it's going to be a positive exponent. All right. Now, we can go back. We can go and rewrite this as the way it was. Okay, so we can take it from scientific notation and change it back into regular notation. All right, and the way you do that is you would just say, okay, well, 2.5, so I know I'm going to have a 2 and a 5 in there. I have to move this decimal 9 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is where my new decimal is going to be. So when I do that, I'm adding where all these empty spaces are, that's where zeros are going to be. So 1, 2, 3, 4, 5, 6, 7, 8. So I need to add 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and the reason why we're doing this and the reason why we know to move to the right is because, once again, this is positive, so the exponent's positive, which means the original number, was greater than 1. Okay, so if the exponent is positive, let me do that way it doesn't look a T. So this is a positive exponent. That means the number was greater than 1. So that's the reason why we move the decimal to the right whenever we rewrite it. So that's going from out of scientific notation into scientific notation. Okay. Do that. And we're going to move on to the next one. Okay, so this one here, we are going to now we look at it. So it's the same thing. So we're going to write this in scientific notation. Remember, the first step is always to determine where is the exponent. Where is the decimal going to go? In this case, our number has a decimal. Okay, and if you take a look at this, our number is less than 1. So our number has a decimal. So now we just need to determine where are we going to put this decimal so that the number that we end up with is between 1 and 10. So remember, you move the decimal to where there's only one number to the left. So we're going to move it from here to between the 5 and the 7 because we only want one number to the left. It can't go in front of the 5 because then that's 0.579, and that's less than 1. It's got to be between 1 and 10. We can't put it behind the 7 because then that would be 57.9. That's greater than 10. We can't put it at the end because that would be 579. That's also greater than 10. So your number has to be between 1 and 10. So you move the decimal till there's only one place to the left. Next step is to figure out what our exponent is going to be. So we do that by determining how many places we move that decimal. So 1, 2, 3, 4, and then to right here. It took us 5 times to move that decimal. So then we rewrite it in this form, m times 10 to the n. So our m was our number that was created by moving that decimal, so 5.79. The n is our exponent, which is the number of places we moved it. So we moved it 5 times, right? So we know the exponent's definitely going to be a 5. but is that going to be a positive exponent or a negative exponent? In this case, the exponent is negative because the number we started with was less than 1. Okay, remember this number was less than 1. So if the original number is less than 1, then we have a negative exponent. Okay. Once again, we can take it from scientific notation and take it out of scientific notation. So we're going to go from scientific notation to regular notation. So once again, to do that, we're going to write or actually just leave it like if you have this on paper, or even if you don't have it on paper, you can just take scratch paper. So this is my number I'm starting with. This is my exponent. My exponent's a 5. It's a negative 5. So this negative here means that my original number was less than 1. So negative exponent, number was less than 1. Okay. So that means I'm moving it 5 times, but I'm going to be moving it 5 times in the direction that gets me a number less than 1. So which way do I move the decimal to get me a number less than 1? Do I move it to the left or do I move it to the right? And we would move it to the left. So I'm going to need to move it to the left 5 times. So 1, 2, 3, 4, 5. So this is where my new decimal is. All these blank spaces here where you put zeros. 1, 2, 3, 4. So my number was 0.0, make that decimal bigger, 0, 0, 0, 5, 7, 9. Sorry, it's a little hard to write with the mouse. Okay, so we can write into and out of scientific notation. So this is a skill that you need to have. The next topic we're going to look at is how do we calculate using scientific notation. And we're not going to do it this way, so give me a sec.